I mean, maybe. Miss Gafford's brand new, right? Miss Gafford's brand new to Phoenix. So, Gold Diggers Gulch.
That looks so fun.
So during a field trip to the minor 49er amusement park,
Is it in California?
you would assume, right? Since we're talking about digging gold and 49ers and things like that.
It's actually in like France.
I don't know if they, well, I'm sure they have like amusement parks, but I don't know if they do like we do with amusement parks where it's like tons and tons of money invested. Because they like, you know, have free healthcare and stuff like that in other countries.
Disneyland France?
Yeah, they have Disney like in every country, I think. Because Disney is just like crazy.
Disneyland Antarctica. That's where I want to go on vacation.
All the rides are just ice.
That's going to be my discovery day.
Actually, sadly, the ice is melting. All right, so let's do some math. The car starts in the parabolic part of the ride. What's the name we're using here? There was a name. I lost it.
Gold minor.
No, there was it said something about like a kid notices, but okay, whatever.
Alfredo.
Jeffrey Alfredo. There we go. Jeffrey Alfredo notices that there is. Well, okay, yes, thank you, but he already said Jeffrey. Sorry, they already said Jeffrey, and I like it. Jeffrey Alfredo, or Alfredo Jeffrey, notices that this is a parabolic section. So we're only going to look at the parabolic section of the ride.
This isn't just the whole ride.
No.
Okay.
Although, have you been on the corkscrew at Cedar Point? It literally just goes up, back down, up, back down, up, back down, up, back down, and you're done.
Yeah, but it's fun.
Well, yeah, because it like spins too. But
Yeah.
so, if we were going to try to model this like as a function, which legit, like engineers that are designing roller coasters have to model these things and make sure that in the like most extreme situations, so like nobody on the car and a lot of people on the car weighting the car down, that the ride will work how it's supposed to. There's a lot of physics involved.
Yeah, you don't want the roller coaster just flying off.
Have you ever seen, well, probably not because you guys haven't been there in a while, at Cedar Point, the Millennium Force, no, not Millennium Force, that's a good ride. Top Thrill Dragster. There are times when it misfires. And literally, it goes and goes up and doesn't make the top of the hill and just comes back down backwards. Seriously.
Okay, but
And then
It's-
they just fire it again until it goes.
Right. So it's not really a design flaw. It's like an energy flaw, really. And this is beyond really my expertise. But
yeah.
it fires by electromagnetic like force. It literally just sits there and like charges up and then, and yes, sound effects. So when it doesn't fire with enough energy, it can't make the hump.
But it just goes back down instead of like falling down.
Well, it doesn't like come off the
It's
track.
like in the track.
Yeah, it's like 3 sides wrapped around the track, so it's safe.
Okay, yeah,
It would still be
I was
freaky though.
I was just thinking, wait, roller coasters aren't just set on tracks.
Correct.
Are they?
Yeah, they're wrapped around the track. So,
No. Yes.
I thought they
Sitting
were
on
like
the track.
so we're gonna need a piece of paper out to write on. If
I
the
just
car is 300 feet above the level of the ground, and we've got some other measurements given to us there, that's a 50.
So what
in
you're
case
saying
you-
is, well, I don't know if the 50 is all that important.
So the level of the ground is what we're going to use as our zero height.
Yeah. So we kind of have 3 points already. We have negative. Right. We don't even know how deep that is. No. The bottom of the. Oh, maybe we will need those. We have 4 points, I guess.
Oh, that actually looks kind of terrifying, seeing as it's 300 feet and it's going at such a sharp angle.
Because we have like.
Yeah, that's a football field, right? 300 feet is a foot. So you go 300 feet down and you only go 50 feet over. That slope would be like -6. So the question is like, what degree angle is a slope of -6? And we can figure that out. But yeah, so it's steepest at the very top, and then gets a bit more gradual. I have a dog hair.
We currently have. Let's get back to. Well, I guess that is math.
So I'm gonna stop talking and just let you guys do this.
Guys, we kind of have 4 points, right? We have 50, 0, -50, 0, -100, 300, and 100, 300.
think it takes a lot of effort to be as loud as they are.
No, it doesn't take a lot.
So we have 3 points. We've got 0, 300, 50, 0, 150, 0.
No, we have 4 points. Wait. 0, 300? Oh, you're graphing it from that way. I was graphing it with like the middle of the parabola in the middle, so we don't have to like.
I was graphing it on.
So the blue lines I've given you are my suggested axes, so we all have the same equation.
And because that would make sense in real life, because the blue axis, the x-axis is the ground.
Well, the x-axis makes sense, but I feel like the y-axis should be at the middle of the parabola.
So what Connor's arguing
Because then you don't want,
is
because then it should, I think it'd be easier.
this,
Yeah.
which we could do that, but I'm asking you to do this, so it's actually a tiny bit tougher.
What?
Because then you'll be able to do any situation. If you practice harder than you have to perform, then you're ready for the performance.
Yeah, that makes sense.
So we have to solve for the parabola.
Wait, what points do you guys have?
Well, I'm changing my points because Mr. Hudson is mean.
He's not mean, he's right.
No, he's making it harder. And he knows he's making it harder. So I call that mean.
Okay, buddy.
Even if it's mean for a good reason.
You don't think your teachers have ever made things harder for, like, just because?
No, I think they've done it. I just think it's rude.
Says Connor.
Exactly. If I say it, like.
What points do you have?
I have 0, 300, 50, 0, 150, 0.
50, 0. Where is that? 50.
So we basically need an equation that all of these points fit into. Perfect.
50, 0. 150, 0. 0, 300. Now we have this point here, which is annoying.
Wait.
We could do a fourth point.
Yeah, wait, what about this one?
We don't need that one.
I mean, we could. I mean, you're right though. It's
It's
reflected.
more useful to use it that way.
Which would be
200, 300.
Wait, is there a way when we're given the x-intercepts to figure out the vertex?
Yes.
Remember, those are two different forms. You guys figured that out yesterday when you solved that one quadratic in two different ways, and you both actually had the same thing.
Okay, so we have. What do we have?
Alright,
We
so
have
we got.
So I
x
don't.
minus 50,
I
x-
don't think we can use vertex form here. Is the like? I don't think we can.
I'm gonna try.
Okay. If we don't know the vertex, how are you gonna try? I'm just curious.
Because I'm gonna figure out the vertex.
You're just gonna like guess a vertex and see if it
No,
works.
I have a methodology that I'm
Okay.
gonna try.
All right.
You guys do whatever we're supposed to do, and I'm gonna do this.
I mean, this is like when Jake derived his own theorem with what was that, polygon angle sum area, something like that.
Yeah, we're doing polygon area theorem.
There you go.
Two.
I mean, you guys are smarter than me, as I've said. You always have to make sure that you're not mean to the people that you're smarter than.
Square minus. Oh, I remember how to do this now.
Well, I'm gonna do it fine.
And then there's actually who's like, well, if we have technology, we might as well use the technology.
Desmos.
It's what she has pulled up already.
Graphic calculator. That's
You
no.
know that.
Oh yeah, I just didn't see that you had your calculator out already.
Connor, you're a bozo.
Whoa.
Whoa.
Just use the-
Bosons are types of particles. You calm down. A boson,
Yeah, that's not what I called them though.
I know. I'm just trying to relate it back to science and math and things.
I think I got it.
Bozo.
I get x minus 100 squared minus 2,500.
Wait, we're 2,500 feet in the ground?
Maybe.
I
It's
don't
a
think that's
long
right.
roller coaster.
Well, I could plug it in for the other points. Wait, we could add an outside thing to shrink it a bit. Wait, no, we can't do that. That would be bad.
Well, you could put an A on there. question is, would that change how deep it went?
Yeah. It'd make it go deeper.
I mean, it's your roller coaster.
But, oh, you can put negative on it, though. Or, no, a fraction of an A. To make it go
You can make A fractions. I mean, that, yeah,
A
that's
fraction.
true.
I'm going to plug it in for one of the points and see.
Two variables.
300 equals x minus 100. So equals.
So I don't think we're
No, I
actually.
didn't do it right. I know
Did
I
he
got
just
it.
say that?
He did.
Dang, I missed it. I don't think we'll get to 922 today, so I'm probably just going to tell you what problems are critical for tonight.
Guys, it didn't work. But why?
Your coaster got stuck underground. You went too far. The people are just screaming from inside there.
I just tried to plug in some.
I found it.
Didn't quite work.
Found what?
The answer. Vertex. But that was just by guessing and checking on Desmos.
Well, I don't think that helps, Jake.
This is backfiring.
Don't share it, please. I want to try and figure this out.
Would...
No, I haven't.
No, like, question. I'm not trying to give you an answer. I have a genuine question. What would be this distance to the midpoint, or to the vertex? From here to the vertex. Another 50. Would we expect it to go further horizontally, or sorry, further vertically, or less vertically than what it did here?
Less.
We'd expect it to be less, right? Because it like weakens. It's continually getting more gradual. So we're going to guess that this is less than 300. And pretty safely guess that that's going to be less than 300. So this value is probably higher up than negative 300. So something between 0 and negative 300. So if we get a very large number, we should probably be speculative that we might have made an error.
Or we didn't do one part yet.
Do you think you have it?
Wait, that would make it bigger.
What would... we don't know what you're talking about. Or are you just kind of talking to yourself?
Oh, that's because I did it wrong. Okay. That's why that would make it bigger. Because I did it wrong. That makes a lot of sense. That's not a nice number. How do you turn something into a fraction? Because I think this is a fraction.
I mean, are you asking like in your calculator?
Yeah, on the
Or hit math?
Math?
Hit math and then frac. Go over to number if it's not already on number.
5/14. It is a nice fraction. No, it's not like that. Okay, I think I got it. This might not be the answer you got, but I think this works. Question mark. Let's see.
So I think something you all agreed on. I think I'm going to write that down because I think we all agreed. I think we all agreed on that, yeah?
What?
I think we all agreed on x minus 50, x minus 150. Because these points, if we use the y-axis over there, so then what is 150 times 5? 15 times 5. Yeah, sounds right.
Yeah. And then I tried to put it into the. No, not 750. You need another zero there.
Oh, 7. My bad.
I might have said it.
Those 10 places. Stupid decimal. By the way, I made this for Math 8. But if you're curious what after you get past like million and billion, I have a little chart over here. Yada, I find this really funny. Yada is 10 to the 24th. Zeta is 10 to the 21st. Exa is 10 to the 18th. Peta, and this was dangerous with 8th graders. Peta was 10 to the 15th. Tera is 10 to the 12th. And then we get back to giga, mega, kilo, those things that we know. Prefixes. Prefixes for crazy big numbers, right? Speaking of Terra, you ever play Terraforming Mars?
Actually, I think Mars.
I have not yet, but my friends, I watched them play and it looks fun.
I don't know how it works, but I have played it.
Isn't it like a map discovery type based game? Like
Yeah.
you flip over the tiles like as you go. And
I've played the digital version, so that's probably why I had no clue what was going on.
yeah, digital version you can just kind of click and like if it lets you do it, you just do it. So x squared minus 200x plus 7,500. I don't think comes out right.
No, you have to add another 2,500.
Am I allowed to just?
Yeah, you just put it on the other side. Two. You add it to both sides.
So I might move this. You said then just add
2,500 to both sides.
to both. Wait,
It's
but then it
y
wouldn't be.
equals that. So it's y plus 2,500 equals.
But that wouldn't. Then I'd have to subtract to get back to y equals form.
So wait, I'm confused.
Yeah, but you can simplify it once you add 2,500 to both sides.
I'm still confused, but I'll follow your lead.
This is probably not the best way of explaining this.
Y plus. So you're saying this?
Yeah, and then you can simplify x squared minus 100x plus 10,000 to be just x squared minus 100x squared. Because 100 squared is 10,000, and negative 100 squared is also 10,000.
Does that get these points that we said are for sure?
No, but that's when after you do that, then you have to add the a in to make it get those points.
I don't think we're allowed to do this. I mean, sure, algebraically we're allowed to add things to both sides, but that's not in function form then.
No, but once you have it so that you can simplify it down to x minus 100 squared, then you subtract the 2,500.
Then don't I essentially get back to this?
Yeah,
Like what I have in purple?
but the purple looks like x minus 100 squared. So it's
But then we're still saying this is 2,500 deep?
It's not.
Yeah.
I think I got
There is you have gone down a bad path. I think we need to walk it back.
Well, you got it from
Jacob?
So I'm confused because I just tried to solve for the coefficient by plugging in the 0.50, and I got that the
Wait,
coefficient was
0.50, where is that from?
50, the point from that.
Oh, the point. Sorry, I thought you meant like 0.50, like decimal point. Okay.
No,
So these.
I plugged that in and solved for
Correct.
the coefficient, and then I plugged it into Desmos.
Now hold on.
It didn't give me the correct thing.
The 0.50 we used to make x minus 50 x minus 150, right? Unless you did something different. So those 2 points are still only 2 points. If I try to use that point again, I'm still only using 2 points.
Oh, yeah.
Is 2 points enough?
No. Okay, we should use 200, 300.
So this we know. Quit erasing, Hudson. This we know to be true. Just that there might be an A out here, or like there might be something else. But like we agree that this is true. So this is true. we also then need to make this true. So, well, if this equals y, then we've got a space for y and we've got a space for x, right?
Yeah, 200x and 7,500 constant.
So then the y was, let me change colors since we're changing
The y was
colors.
200 and the x was
I don't know
200.
if this is right.
X was 200.
Does this look right? I don't know.
So either we can use the y of 300, x being 200, or the y of 300, the x being
There.
0.
Would this work?
Let's find out.
Both of those get you 300 equals 75.
Is 0.04 a nice fraction? I think it is. Wouldn't that just be 4 hundredths? Which I think reduces. I mean, 4 hundredths seems nice.
That's what I got when I guessed and checked on Desmos.
I don't know if this works. But
Does what I've written make sense based off the parameters we were given?
You didn't add the a. Oh, well, yeah. Based on the parameters you were given.
So then what we're saying is, well, this is wrong. Sorry, but you're making noises that make me feel like you're not
no,
sure.
I got it.
Okay. So there is potentially, so it can be, whatever you want to say, like an A out here. And when we plug in 0, the only thing the A would impact, come on, is the 7,500. So essentially, the situation we now have gotten ourselves into is we need to make this true.
And then you have 300.
Yeah, that's what I did. Basically. That I did 300 divided by 750 and I got that. And then it seemed pretty close because the first point I got was, for the ending at least, was 230. So I just then tried.
So wait,
Was a
I
4.
got 300 equals a 200 squared minus 20 times 200 plus 75.
A 200.
He used the 200 point.
You used the 200. That's just going to make some bigger numbers, but yeah.
But it didn't work. I didn't get the same answer.
Let me check what you wrote down then.
That.
Did we check this? Wait, this is 7,500, isn't it?
Yeah, 75.
7,500.
Because this is not 5 and 15, it's 50 and 150.
Yeah, so okay, wait. You just have to plug in a number and then divide and then you put it there and then you put it. Okay, wow. Wow, I worked so hard for it.
You didn't work so hard for nothing. You
Yeah,
worked so hard to have that moment of realization.
Why do parentheses on calculators hate me? When you try and go back and add parentheses, it's always supposed to.
Second delete lets you insert.
Oh, actually, well, thank you, but since there was an exponent, it actually let me just put the number. Thanks.
Wow, look at that. I got the answer before all of you people.
Well, I got the wrong answer.
But I got the right answer.
I got an answer.
Yeah. Okay, well, I don't get why you can't do it the way I did it. Like, clearly you can, but I don't get why you can't.
What was the way that you did it?
Did it? Yeah.
Well, did it? Like,
Yeah.
well,
Yeah.
did it? Was it
So
right or wrong?
I took the plus 70, like, go up to the equation, and then basically I made it so that if I completed the square, and then I added the negative thing like we did yesterday.
What did I do? Oh, I know.
So the issue with what you had done is algebraically it's sound. You're allowed to add things on both sides, and the equation is still equal. Good lord.
We just did one.
Welcome to like college math classes. You walk in and an hour later you haven't even solved one problem.
That sounds so fun.
You've gotten a lot of wrong answers and wrong ways to
What do
do
you
it, and
mean?
your prof is
I-
like, "Yup."
I did it right.
I mean, you are right. You can brush that dirt off your shoulders if you want to.
Wow.
So the issue with what you did is we were still only working with 2 points, and you were like still trying to force all of that to be true with like adding things on both sides, whatever. But then once y is not alone, it's not in function form because y needs to be alone, like f of x, right? So when you added on the left-hand side, it started messing things up. Does that make sense?
You could do that yesterday and it worked fine.
I don't know if I remember what you were
What problems do we have to do for today's one?
That is a good question. I would love you to say all of them, but I want to try to make your guys' life easier because I know ELA has like a big old thing.
Well, if it's not due tomorrow, you can make it so it's all of them.
The more important questions, if you guys want to write these down,
I'll just do it.
would be, 54 is good practice. 55 we should do. That should be relatively quick because it's just figuring out what type of function it is. You can skip 56. 57 we should do, especially after what we just did and kind of struggled with. So essentially skip 56. You can skip 58 because that'd just be easier for us to do and use the tools in Desmos.
Still don't get it. I still got the wrong answer.
I'll come and check your work in a second if you want. Do 59. And 60, I don't think you guys need to do. It's essentially application of distance
You
formula.
Do 54, 55, 57, 59.
Wait, but we didn't write that in vertex form. Did we? Because it was x squared. It was like a trinomial.
We can pick this back up on Tuesday. I think you're right that we need to then convert it to vertex form, but we know what the A is now. The A is 125th,
Yeah.
right? So we know the A. This is 200. This is 75. Oh, you redid that.
Bye.
Oh, have a great day. You jumped right to forcing this to be true. I don't know if I love jumping right to that.
Wait, Mr. Austin, do you want us to revise the last year since we talked about it?
No, because we talked about it together. That's fine. Let's pick this back up. Probably like a simple pick state. Okay, so you added that to both sides. So 32, 5, 2. That's a 5, not wait, no. That does turn into 8, doesn't it? I'm assuming. Connor, you might be able to find this a little quicker than I can. There's a bunch of research that says it's definitely not 120. I feel like we have like an arithmetic mistake somewhere. So that's 40,000.
All the kids are saying it's good. They say the kids are saying it's good.
So if we do 300 plus that gets 32,800.
I don't understand how it's wrong.
Wait, it's 200 squared. Wait, how did you get 40,000 from 200 squared minus 200 squared?
Because this is multiplied by A, so you can't do that.
Oh, our A is on the outside of all this. We need parentheses here because A is going to apply the whole thing.
Oh.
That, I believe, is where then it went
Okay,
wrong.
that makes sense.
That was a good question, Connor, and that was good pressing me, Jake, to like continue to say, wait, I don't get it. Because wrong answers lead us to the right answers. I mean, sometimes we can just get to the right answer, but a lot of times we got to find some wrong answers first.
Yeah, because not all
Okay,
of
now I
them
have to
are
do
right.
it.
Did you say it should work out now, Jake? Have a good day, Connor.
Right answer now.
So, oh, I am still recording. That's a thing.
Hi, Steph. Hey, Steph.
Who, what?
Hi, Steph.
Thank you. Why I actually did that is when